Okay, hi and welcome to Note 6.4, which is about point-slope form. Last couple of days we've been talking about different forms of linear equations, right? Equations with a constant rate of change, making them align visually. So if we look at the first form we talked about, which was the slope-intercept form, we could easily see our slope and we could easily write an equation if we had y-intercept. So it's good for writing equations with y-intercept. And it was also good for graphing. But what happens if we don't have a y-intercept? Well, we'll get to that in 1 second because we're going to use this point-slope form right down here. Now, the other form we talked about was standard form. It's okay for graphing, especially if we want to graph by intercepts. Okay, so let's write that down. So if we graph by intercepts, it was great, or if we needed to know the intercepts, it was also good. Outside of that, we couldn't really see slope in it. It was really nice for writing some situational problems that we come up with, especially if they talked about two variables, so we couldn't write specifically one in terms of another. But now we have a third form, which is really good for writing equations, and that's kind of where its specialty is. So if we need to write a formula or a function, we're going to use this point-slope form. And it looks kind of funny. It says y minus y1 equals slope times x minus x1. What does that mean? Well, slope's pretty easy. You can see that. There's m. So you identify slope either from the graph or from a couple of points, and you plug it in. Now the y1 and the x1 refer to a second point. Any point they can be. So any point that you're given for this linear function, you put in y1 and x1 in these locations, and you put in slope, technically you're done. That's an equation for a line. You don't have to change anything. You don't have to solve for b like you did in slope-intercept form up here. Normally we'd have to solve for b. We don't have to do that. You plug in any point you can find in the slope, and you've got an equation. It's great. Nice, easy way to write from it. We can graph from it because we can see a point and we can see slope. Super easy. The only thing we can't really see is the y-intercept. We can change this form, though, pretty quickly. So that's what we're going to explore today. Let's practice really quick graphing from it. Again, our only thing that we have to identify to graph from is location. Here is slope. So let's write that down. This is slope. M equals that. Okay? And then our point, if we remember, is this 5 and this 2. Now let's go back up and look at that equation just a little bit. Notice that these are both negative values here. So this is a negative between y and y1 and x and x1. Those are both negatives. So if we see them there, we have to understand that our point, and be cautious with this, our point is actually, here's my x-coordinate, positive 2 and positive 5. Okay, so that's the tricky part about it. You have to remember that these are negative. So if we plug in negative values here, these two negatives would make a positive, and such the same over here. So you just have to watch the sign switch. Whatever the sign is there, it's the opposite for the points. Okay, so let's plot this because we've got everything we need. Let's plot our 0.25 over 2 up 5. 1, 2, 3, 4, 5. There's my point. And now I'm going to go ahead and do my slope, which is rise over run, positive 1, positive 2. So I'm going to go up 1, right 2. I can repeat, and I can go the other direction, down 1, left 2. So I'm going to go ahead and do that a few times, and then I can draw my line. Whoa, again, pretty tough. I know I missed, but you get the idea. Okay, so there's the equation for a line. Graphing, pretty easy. Looks funky, but is easy. All right, so let's practice writing into the form. Again, we need any point. So here's our point. Here's our slope. They already gave it to us. Sometimes they will, sometimes they won't. In this case, they did. So we're going to start writing this out. Here's the general form. I highly, highly recommend that you start by writing down this form. Okay, so then you just got to match parts. You can even label them if you want to. You can label it, hey, this is x1. Hey, this is y1. Hey, there's my slope. So I'm going to write down y. That's this y here. And it's a negative y, which is 7. I'm going to use parentheses just so I can highlight the fact that I'm going to have two negatives coming up here in a second. I'm going to put my slope, which is negative 3. So far, so good. Here's the x. Here's my x1. Now it's a negative 1. It's supposed to be a negative in the problem. So I'm going to put minus negative 1. Some of you will change that immediately. They'll just change it to a positive, which we're going to do now. So I'm going to go write this the simplified correct form, which would be y equals negative 7. I don't need the parentheses at this point because they got multiplied in. And then I'm going to take these two negatives and make them a positive. And then I'm done. That's the equation for that line. All right, and then the last problem we got to do here, let me scroll down a little bit, is if we're going to write it from an actual graph. So this time, notice they didn't give a slope. So we're going to go ahead and find slope. We can do it by rise over run, or we can calculate it. since we have a graph, let's rise over run it. So I'm going to count how far up I got to go. There's my rise. Again, always starting from the left point. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going up 8, and then I've got to count how far I'm going over. It's a positive 8, and I'm going over 1, 2, 3, it looks like. So positive 3 and positive 8. Okay, so those are my two values. So I'm going to write that slope in. I'm going to do that first. So 8 over 3. And then I need any other point. I'm just going to write in the pieces that I already know go there. So these are subtractions. So really all I have to do is find that x coordinate, find that y coordinate, and I'll be done. Take either point, doesn't matter. It's okay if they look different. When we change its form, it'll end up being the same. I'll show you in the next part. All right, so I'm going to take 2 and 3. There's my x1 coordinate. There's my y1 coordinate. I'm going to go ahead and plug them in. y1 was 3, so I'm going to write a 3 here. My x1 was positive 2. I'm going to write a 2 here. There's the equation of my line. All done.